Hello students. In my previous presentation, we have seen hierarchical agglomerative clustering using single linkage. In today's presentation, we shall see complete linkage hierarchical agglomerative clustering followed by average linkage. So with respect to both of these concepts, I have not solved the entire example, but I have given you the first set of steps, so that you can try solving the entire problem by yourself. I have also put down the final matrix which has to be coming as a final answer, and I have also put up the dendrograms for each one of these techniques. So first of all, find clusters using complete linkage. Use Euclidean distance and draw the dendrograms. Now, what was the difference between single linkage and complete linkage is that in single linkage cluster, from the initial distance matrix, we find the distance which is minimum. We find the minimum distance, or we find the objects which have got minimum distance between them, and we cluster these objects, and then to represent a value for this cluster, we find the minimum among the cluster, minimum between the newly formed cluster and other data objects. But when it comes to complete linkage, once we find the minimum distance from the distance matrix and we merge the data points into cluster, we find the maximum distance between the newly formed cluster and the other data objects. So this is the difference. And when it comes to average link cluster, we find the average value of the newly formed cluster with the other data objects. So first we shall concentrate on complete linkage. So find clusters using complete linkage, use Euclidean distance and draw the dendrogram. So this is the given data set to you. First of all, like how we have done in single linkage cluster, we apply Euclidean distance in order to obtain the distance between every pair of objects, and we come up with a distance matrix as shown here. We come up with a distance matrix which is shown here. Now, in this matrix, we have to find the distance which is small. That is, we have to find those two data objects which are very, very close to one another. So when I see this, this is 0.11 is the smallest value here. So it has been highlighted. Find the minimum distance. The 0.11 value is the smallest. So I can merge P3 and P6. So when I merge P3 and P6, my matrix is going to look like this. So I have the value for P1 to P2, that is uh, P1 to P2 is 0.23 here. There is a typos here, sorry. P1 to P2 is 0.23, P1 to P4 is 0.37. So values which are already present in the previous matrix are put down as it is. Now what is that we have to find newly is the distance between the newly formed cluster and the other data objects. For example, here the distance between P3 P6 cluster and P2, distance between P3 P6 cluster and P1, here distance between P4 and P3 P6 cluster, distance between P5 and P3 P6 cluster. Now in the single linkage, what we have done is we have found the which among the distances are small, whether P1 to P3 is small or P1 to P6 is small, and we have replaced this question mark in this box with the minimum value, that is the smallest value. But in complete linkage, what we are going to do is we are going to find the maximum, whether P1 to P3 is maximum or P1 to P6 is maximum. So P1 to P3 is 0.22 here, P1 to P6 is 0.23. So the maximum of 0.22 and 0.23 is 0.23. So this box here is going to contain 0.23. Similarly, the maximum of P2 to P3, P2 to P3 is 0.15 and P2 to P6 is 0.25. So the maximum is 0.25. So we find out the maximum between the newly formed cluster and other data objects, and then we replace the we put those values in the box. So we progress like this. Next, once again, I have to find the minimal value here in the lower half, that is 0.14. Then I can combine P5 and P2. Then once again, I have to find the distance between P5, P2 cluster and other data objects. So likewise, we continue doing it. And finally, my matrix looks like this. So please complete this steps which are there in between. I have just found out the first cluster, the distance matrix using the first cluster, and the final cluster I have put up here. And this is the final dendrogram. This is called the dendrogram here. This is the final dendrogram which I have put it for you. So the answer should come something like this. Now this is with respect to complete linkage. Now how about average linkage? In the average linkage also, there is a typos once again. This is find clusters using average linkage. This will be rectified in the PPT. Find clusters using average linkage. So this is the data given. Once again, I have to find the distance matrix by the application of Euclidean distance. So first step, what I do, I find the minimum value in the lower half. So it is 0.11. It is marked here. So I can club P3 and P6. P3 and P6 is clubbed here. It is clustered and the matrix looks like this. Now other values are already available. P1 to P2 is already available, that is 0.23, and P1 to P4 is available 0.37. Now what is it that is not available? That is distance between the newly formed cluster and other data objects like P1, P2 or P4, P5. Now what is the value that I have to fill here? Now here, instead of finding the minimal distance between the newly formed cluster and the other data objects, or finding the maximal value between the newly formed cluster or other data objects, I should be finding the average distance of P1 to P3 and P1 to P6. So P1 to P3 is 0.22 here and P1 to P6 is 0.23. So average of 0.22, 0.23 comes out to be average here 0.23. So that is filled with this. Once again, I should be finding the average distance between P2, P3 and P2, P6. So P2, P3 is 0.15 and P2, P6 is 0.25. That comes out to be 0.2. So like that, I have to fill other values also. So once again, I have shown you only the first step. So you have to continue doing this until you get the final distance matrix that I've put up here. The final distance matrix looks something like this, and this is the final dendrogram. This is the final dendrogram. Now, if we try to compare all these three techniques under hierarchical agglomerative clustering, the first technique, that is a single linkage, which tries to state the minimum distance between the newly formed cluster and the point in this in the other data points. In this case, what happens is the distance between the newly formed cluster and the other object, we place a value which is a minimum. So when do we get a minimum value? Only when the points are very close to one another. So this newly formed cluster is very close to the data object which is already there. So this is what the single linkage cluster talks about. But when it comes to when it comes to complete linkage, we find the maximum distance between the newly formed cluster and the other data objects. That means that the points are very much far apart, which gives a guess that the points might be outlier. We get a maximum distance only when the points are very far apart, and very far apart here means that the data points could represent an outlier there. So in order to overcome the drawbacks which are there, it's not a drawback, or I can say that in order to best represent the distance between the newly formed cluster and the other data object, it is always better to take the average, and that is why we have uh, the average linkage hierarchical clustering. That's all with respect to hierarchical clustering. Thank you very much.